Okay, we are Thursday morning, October 6th, 2022, and we're working on we're starting section 2.3 on rational numbers with using fraction operations. And we're doing a review here from grade 7 and 8 on different questions you would have encountered in grade 7 and 8. So the first question says 1/2 take away 1/5 times 3/4. So we actually have more than one operation here. A half take away a fifth multiplied by 3/4. So because we know that when we have more than one operation, we need to follow order of operations, we need to do our multiplication first, which really asks the question, do you remember how to get the answer to the product of two fractions, which is really easy. So the first thing I'm going to do before I even consider what the product is, that I'm going to bring down that 1/2 takeaway. Take away whatever this product is from a half. In order to get the answer, we remember that we actually have to multiply our numerators and multiply our denominators to get the answer of 3/20. Once we get that answer, we now have a simpler one of 1/2 take away 3/20. With subtraction, we need common denominators. I think most of you remember how to get common denominators. It's the first multiple that both 2 and 20 share. An equivalent fraction to 1/2 that has a 20 denominator is 10/20. And an equivalent fraction to 3/20 is just going to be 3/20. So we're on the home stretch here. We have 10/20 take away 3/20. Our rule is to subtract the numerators and keep the denominator, which means our final answer to this BEDMAS question is 7/20. If this was a test, I always like it if you circle it, or if you have a highlighter, make sure you highlight it so my eye can be drawn to your answer. We will be posting this online, so if you do want to copy it down after, just try and copy down as much as you can right now, and then if you miss some, you can get it on the Google Classroom. Our next question is two operations as well. This time we have a division that we're going to do first. So I'm going to bring down the 3/4 plus, and now I'm going to figure out what is this as a solution. Back in grade 8, when you learned how to do it, you realized that 4 is really 4 over 1, and the simplest way to divide by fractions is to multiply by the reciprocal. So we're going to change 2/5 divided by 4 to 2/5 multiplied by 1/4, or 1/4 of 2/5, which makes sense when you consider dividing by 4. Multiply the numerators to get 2, multiply the denominators to get 20. Now some people in this room, I know they exist, probably knew that when multiplying two fractions you can cross reduce. And they probably looked there when multiplying two fractions and reduced it to 1 over 2, in which case you would have got 1 over 10 as your second fraction. That's great if you did, but really it didn't matter because your common denominator is going to be 20 anyway. In order to get your equivalent fraction, you're going to multiply both. You're going to get 15 over 20. And this time, your final answer is going to be 17/20 because you're going to add the numerators and keep the denominator. Oh, shoopsie doopsie. In the third question, we have 2/5 multiplied by 3. Now, even though I don't have to, I am going to just remind you of what this looks like. So if I was to draw 2/5, that's what 2/5 would look like as a picture. And if I was to take that and through the miracle of smartboard technology, group that into one fraction, oops, infinite cloning. And then, oh, this is not going very well at all. Infinite cloner. Double it, and triple it. Oh, that didn't work out at all. Ungroup. I should have paused this. But, heavens to Betsy. Okay, I messed that one up. There's 2/5. If I tripled it back in grade 8, there's doubling it. And there's tripling it. Heck with the infinite cloner. What we then said is, if you triple 2/5, how many fifths do you have? And we figured out that we have 1, 2, 3, 4, 5, 6. We have 6/5, which is actually your answer, or 1 1/5. So through modeling, that's how we got our answer. Through an algorithm, we realized that whole numbers can really just be expressed over 1. And if we multiply our numerators and multiply our denominators, we ended up with 6 over 5, which is still as an improper fraction, or as a mixed fraction, 1 1/5. So that's your answer to question number 3. Question number 4, oh, for heaven's sake. Question number 4, we had 4/5 divided by 3. Going back to the modeling, if I was to take 4/5 as a fraction and draw it, I'll use my fancy Nancy highlighter here to shade that in. There's 4/5. And if I was to divide that between 3 people, I could have this for myself, one that's for friend X, and one that's for friend Y. And if I said, if I had 4/5 of a chocolate bar or 4/5 of something, and I divided it between 3 people, what fraction of that 4/5 do I get to keep? Since I'm W, when I made those cuts, it's now at a 15, and the parts of those that I get to keep are just 4/15. So from a drawing perspective, if I have 4/5 of something shared between 3 people, I get to keep 4/15. That's the answer. If I think of it from an algorithm standpoint, 3 can be considered as 3 over 1. Keep the first fraction and multiply by the reciprocal. That's our way to get our answer. We would still get 4/15 of the answer just using the basic algorithm. Question 5, is 1. Oh, for cooler gravy sake, wrong page. 1 1/4 multiplied by 2 2/3. The modeling everybody hated because it was so labor intensive. If this was a rectangle and I said that the length was 1 1/4 meters long and 2 2/3 meters long, then you would know that the area inside there would be the product of 1 1/4. And therefore, sugar cubes in the holy whatever. If I was to say, what if I broke up this length instead of saying this is 1, and from here to here is 1/4, and from here to here is 2, and from here to here is 2/3, then I could still achieve the same idea of what 1 1/4 is by 2 2/3 by finding 4 separate areas and adding them together. We would have got 2 here because 1 times 2. We would have got 2/4, which is a half. 1 times 2/3 is 2/3, and 1/4 times 2/3 is 2/12, which in lowest terms is 1/6. When I add those all together, I would find the product of 1 1/4 times 2 2/3. We're not going to do that. The easiest way to do it was to think about 1 1/4 as an improper fraction, and to think of 2 2/3 as an improper fraction. Once we have that, we can multiply our numerators to get 40, multiply our denominators to get 12, change that back to a mixed fraction, which would be 3. There's 3 12s in 40, with 4 left over. That's not in the lowest terms. Divide both fractions by 4. You get 3 1/3. There are some very smart people, again, who said, you know what, multiplying, I'm going to cross-reduce. 8 over 4 will become 2 over 1, at which point they ended up with an answer of 10 over 3, which much simpler ends up as 3 1/3 by reducing. I hit the right button that time. Question 6, 2 2/3 divided by 1 1/2. We didn't use modeling for this because it was way too complicated to model it. But what we did say is just follow the same premise as before. Change both mixed fractions to improper. You get 8/3 divided by 3 over 2. Change to multiplication by the reciprocal. Can you cross-reduce anywhere here? No. So we're just going to multiply our numerators to get 16. Multiply our denominators to get 9. You get 1 7/9 as your final answer. Question number 7 is a great exercise in why we want to cross-reduce. If you multiply your numerators and multiply your denominators, you get 8 over 72. Some of you might have thought that was lowest terms, but it's not, because both are divisible by, well, you might have said 2 first. And you got 4 over 36, and you're like, hold on, divide that by 2 again. 2 over 18, divide by 2 again, you get 1 over 9. You could have done it that way. Or, much simpler, because you're multiplying fractions, and your teacher last year told you could reduce, cross-reduce that, ended up with 1 over 9 right away. Question 8, 3/4 divided by 5. Considering 5 as being 5 over 1, you're going to have 3/4 multiplied by the reciprocal, which is going to be 3 over 20. It seems like an odd place to put an easy question like that. Question 9, 7/8 divided by 7/9 will become 7/8 multiplied by the reciprocal, which is 9/7. If you don't cross-reduce, it made it difficult, but if you do cross-reduce, it makes it simple. 9 over 8 is your answer, or 1 1/8 if you change it to a mixed fraction. And finally, question 10, 1/2 times 3/4, take away 1/8, put this in brackets. Common denominator is 8. That will be 5/8. Notice how the 1/2 times stays where it is. Multiply it out, you get 1 times 5 is 5. 2 times 8 is 16. Your final answer is 5/16.